K1 and K2 are roots of viscous damping system, then match the following. Here there are two lists. In list 1, here the terms are over damping, under damping and critical damping, and list 2 terms are roots are equal and real, roots are real and unequal, roots are complex conjugate. Here first for over damping, roots are real and unequal, so that is P matches with 2, and in under damping roots are complex conjugate, so that Q matches with 3, and in critical damping roots are equal and real. What is the natural frequency of vibration of mass M attached to the end of a cantilever beam of length L and flexural stiffness EI? So here the natural frequency is nothing but is generally represented by G by delta. Here a mass M attached to the end of a cantilever beam of length L, so that here the deflection for a cantilever beam subjected to or carrying a point load at the free end is given by WLQ by 3EI or mg LQ by 3I. Now substitute this delta value in the given equation, that is mg LQ by 3I, so that here it is equal to root of 3I by ml cube. So here the natural frequency is 1 by 2 pi root of 3I by ml cube. So in the option, the right option is B. Tensile stresses at a point across two perpendicular planes are 18 Newton per mm square and 14 Newton per mm square. It's obliquely on a plane at 20 degrees with the major principal plane. Find the intensity of stress on the oblique plane BE. Take Poisson's ratio is equal to 1 by 4. Here on the oblique plane there are two stresses induced. One is normal stress and another one is tangential stress. Let us say sigma t. So we will have to find out the intensity of these two stresses. Let us say this is a resultant stress. So here resultant stress is equal to root of sigma n square plus root of sigma t square. So here sigma n is the normal stress and is given by sigma n is equal to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma 2 by 2 cos 2 theta. Here theta is the oblique angle, that is 20 degrees, and here sigma 1 and sigma 2 are 80 and 40. From this equation we can have sigma n is equal to 75.32 Newton per mm square. And coming to the sigma t is equal to sigma 1 minus sigma 2 by 2 sin 2 theta. So which gives a value of 12.86 Newton per mm square. Now the resultant stress is equal to sigma n square plus sigma t square. It is nearly equal to 76 Newton per mm square. So in the option, the right option is C. C is the right answer. A hole is to be punched out of a plate having a shearing strength of 281.48 Newton per mm square. The compressive stress in the punch is limited to 351.85 Newton per mm square. Compute the maximum thickness of the plate from which a hole 63.5 mm in diameter can be punched. So here we will have to find out the thickness of the plate can be punched. So in generally in punching there are two types of failures occur. One is compressor and another one is shearing. So here the limited stresses for both the cases given. One is sigma c is equal to 351.85 Newton per mm square, and here sigma s is equal, that is shearing strength, is equal to 281.48 Newton per mm square. But here compressive stress induced in the member is equal to the load applied on the member and the area, that is pi by 4 d square, compressive area. This is the compressive area for a hole, and here we can find out the load acting on the member, that is sigma c into pi by 4 d square. So here diameter is 63.5 mm and sigma c is 351.85 Newton per mm square and into pi by 4 into 63.5 square. From this we can have the maximum load that can be applied on the member is equal to 4.28 kilonewton. So and we know that the shearing stress is equal to P by the shearing area, that is pi dt. So from this we can find out the thickness of the plate that can be punched, that is P by pi d into sigma s. So which gives a value of nearly equal to 20 mm. So the options, the right option is B. B is the right answer. The moment of inertia of the shaded area as shown in the figure about axis AB. So here this is the shaded portion of the given diagram. So now divide this portion into three parts. One is rectangular area and another one is half circle and another one is inner circle. So here the total moment of inertia about the axis AB is equal, here I1 about the AB plus I2 about the AB minus I3. So here I1 is equal, that is moment of inertia of this triangle about the base AB. So it is equal to BHQ by 12, that is 2b whole power of 2b into 2b whole cube by 12. So here the moment of inertia about the neutral axis of the triangle is BHQ by 36, but the moment of inertia about the base is equal to BHQ by 12 plus I2. So this is the moment of inertia of the semicircle, the half pi by 64 2b power of 4 plus here minus, this is pi by 64 power of b power of 4. So now on substituting all these values, we can have the total area moment of inertia of this shaded portion is 1.67 times b power of 4. And in the option, the right option is D. D is the right answer. Following velocity fields satisfy law of conservation of mass for incompressible flow. Here the options are given here. So to satisfy the law of conservation of mass, it should satisfy the continuity equation, that is dou u by dou x plus dou v by dou y is equal to 0. So if it satisfies this equation, then the given velocity field will be satisfied with law of conservation of mass. So here now test all the equations. First consider dou u by dou x. Here in the first equation u equal 3y cube and v equal to 3x cube, that is dou u by dou x is equal to 0 and dou v by dou y is equal to 0. So here dou u by dou x plus dou v by dou y is equal to 0 and it satisfies the continuity equation. Now consider second equation, that is u is equal to 3xt, that means dou u by dou x is equal to 3t and here dou v by dou y is equal to 3t. So here dou u by dou x plus dou v by dou y is 60, so that it doesn't satisfy the equation. And now consider dou u by dou x is equal here y and here dou v by dou y is equal to x and here dou u by dou x plus dou v by doesn't not equal to 0 and it doesn't satisfy the equation. And consider now fourth one, that is dou u by dou x is equal 12x square t and dou u by dou y is equal 12y square t. So it is also the sum of these two also not equal to 0, so that it doesn't satisfy the equation and the right answer is A.